Hello, my name is Tilia Eldorf and I'm presenting a poster about a 2-year project actually that is finished now, and it is about the discovery of etiological events in the biomedical literature. That means in scientific papers. You see a prototypical event here, and I will present some approaches that we took and present our pipeline for this project.
Hello, my name is Dominic Frevel. My poster is about my master thesis. I created a deep learning algorithm to summarize German texts. To train this algorithm, I had to first create a new corpus with using Wikipedia articles. This corpus is also used tomorrow in our summarization workshop. The algorithm is divided into 2 parts. The first part identifies and extracts important sentences of a given text, and the second part creates then abstractive summaries from these extracted sentences. These 2 parts can be trained either independently or together as an end-to-end system.
Hello everybody, my name is Anna Olasik. Together with Fabian German and Mark Silibak, we've conducted a comparative study of 7 speech recognition systems, cloud speech services and open source. We based our comparison on 9 speech corpora containing spontaneous, semi-spontaneous and read-aloud speech. And we used word error rates to compare the performance. Apart from the general comparison, we also conducted several experiments with the goal to understand the correlations between certain spoken language properties and the recognition accuracy. And we also took a closer look at the word error rate to understand how well it reflects the recognition accuracy. We'll be happy to answer your questions. Thank you.
So, hello everyone, I'm Jérôme from the University of Applied Sciences in Neuchâtel. We have here a project that starts with medical abstracts extracted with PubMed. In all of these abstracts, we search drugs, we search targets, and then we use deep learning to say, is there an interaction between this drug and this target, etc. At the end, we have a list of many drug to target interaction, and if we filter and keep only unknown interaction, it becomes interesting. Why interesting? Because medical researchers can take these interactions and test them in laboratory. And for example, they can discover that a drug can treat an unexpected disease. And that's what we call drug repurposing. So that's it. Thank you.
Hello everyone, my name is Ralf Grobmann, I'm CTO at Spinning Bytes AG, and I'll present the collaboration between Spinning Bytes and EPFL, where we present a system that can predict community-level health targets based on Twitter language. We will present an improved model over the one presented by Eichstätt et al. In 2015, where we use state-of-the-art sentence embeddings instead of LDA topic models to get better results. And this approach is unsupervised and allows the generic prediction of health and other target variables at the population community level by just leveraging large amount of tweets.
If you are a regular customer of the Swiss Federal Railways, like I am, chances are high that you might have been in touch with the customer support. And chances are even higher that you got an answer out of it. After the answer, there's also many processes going on behind the scenes, especially for improving SAP services, based on feedback and requests you send. My name is Nadia Keidel. I'm from Sulke. I'm working there as a data scientist, and today I'm presenting with my colleagues Marlies Lichtsteiner from SVB and Paola Bianchi from Sulke our current state of our email classification project. For this poster, we bring not only the first results, which we got with the classifiers, but also our blueprint for the architecture with us, as the operationalization of the machine learning model is quite a big challenge we had to face and solve as well. We're looking forward to share and discuss at our poster wall. Thank you.
Hi, my name is Margot, and I present here work of my master's thesis student, Bernhard, who was looking into how tweets can reflect Bitcoin value. The thing is that most people have maybe observed that the financial markets were a bit in turmoil in the past couple of years, and regular financial models could not reflect that. And the hope was that maybe things like tweets or other social media channels can. And here we present a data set where we actually looked into exactly this connection between what is published in social media, Twitter, and in relation to the Bitcoin value course in the past year.
Hello, my name is Ella Postulka. I'm at the Fachhochschule Nordwestschweiz. I'm presenting a project that was done with a company. We've got a customer who is Gig Platform. Gig Platform is an organization that mediates between employees and employers for usually short-term jobs. We did sentiment analysis, and we discovered that with just annotating 2,500 tweet statements, reviews, we could get about 90% accuracy without using any special science. So this is really good, and I've got some other projects I'm happy to talk to you about. Thank you.
Hi, Ritwan from the Steering Lab. I have a poster about how you can go from raw reviews online about products and services towards understanding what is being said in those reviews, extracting relevant aspects and their attributes, and then trying to map that to coefficients, then leading to quantification in euro, dollar, whatever terms of these products and features, right? So instead of seeing a product as being a combination of individual components, right? Trying to quantify the product's value from the consumer market. I look forward to interesting discussions with all of you during the poster session. Thank you.
I'm Kurt Rührli, one of 4 architects of the system SIMSA. To begin, I need somebody to answer some questions. Who is ready? Okay, may I ask you, are you able to walk a dog?
Yes.
Are you able to stroll a dog? Are you able to barbecue a dog? Are you able to list all your competences related to dogs, to pets, within a short time, ideally with a verb and a noun? Maybe? I doubt it. I think so. Thank you very much. Such NLP tasks have been tackled by Tanja and Massimo from the University of Zurich using state-of-the-art algorithms from computational linguistics. If you would like to know some details, please join our poster session. Thank you very much.
Hello, my name is Philipp Kunčík from the University of Applied Sciences in Chur. I would like to invite you to our post about semantic systems and visual tools for analyzing text, corpora, and communication channels. We prepared a use case where we highlighted how the Swiss media coverage, or how the media coverage in Swiss media was about 4 things internationally and nationally, naming the tax reform, the Swiss gun law, the EU Parliament elections, and the Brexit. Thank you.
Hello together. My name is Egon Vernon, and I like to estimate emotions from written texts. And we did this with 63 short stories. And the first thing we did, we let them rate on violence, well, on positive, negative emotional content by at least 17 students. But I like to estimate emotions from text without the help of people, because that is time consuming, it's rather difficult. And so we used also a sentiment analysis with the same text and a lexical analysis based on a word list. What we then wanted to know if these automatic estimations, sentiment analysis and lexical analysis predict the subjective estimation of these emotions in these short texts. They do in a moderate way, and as well the sentiment analysis and the lexical analysis receive moderate results. And the good thing is, in combination, we have a small, but we have an information gain. And that leads me to the future. We will try to get even better predictions. I'm not the only one who does do this. It's rather complicated, but it makes fun. And if you have questions to the poster, I will be there.
Hello, my name is Toy Sossmann. This is a collaboration of 2 Swiss companies, Helvetia and Scuba. And together we solve a small but very real problem. A large company like Helvetia communicates with thousands of emails with their customers every day. And the data science team of Helvetia would like to use these emails for analytics use cases like sentiment analysis, classification, for triage, and so on. And they have a system to deploy and run such systems in production, which is cloud-based. Sadly, due to company policy, they are not allowed to put the emails in plain text in a cloud environment. So we need to anonymize plain text. You can imagine, or probably know, that this is a challenging problem. And if you'd like to know how we solve this using a combination of name identity recognition with dictionaries, and why we don't just remove the information but replace it by other valid information, then come to talk to us in the poster session.